All right, so having video problems again. So this is another example for 11.5. Okay, so the only example you saw was pretty basic. Here's one a little bit harder. So we want to find the absolute max and min. Sorry if the sound, I'm going to talk loud and then you'll probably be annoyed with my voice, but struggling all around just to get these videos out for y'all. Okay, so if we look at this one, what would we do first to find the absolute max and min? Well, this one doesn't have endpoints, so we only have critical values to check. So what do we do to find those? We do the derivative. So let's rewrite the original. Oops. With the x as an exponent, okay? And then we'll do our exponent rule. This one will become 1. And then it's going to be plus, plus a negative 49 and or minus 49. X to the negative second. There we go. So it becomes a negative 49, and then we minus 1 more. Now let's set this equal to 0. So 1 minus 49 x to the negative 2, where does that equal? 0. So for this one, we're going to add the 1, or excuse me, minus the 1 over first. And then we're going to, let's rewrite the x as in the denominator, because then it'll make more sense. So we're going to write this as negative 49x squared equals negative 1. This will make more sense for what this next step. I could do more of it in my head than I shouldn't do it that way for you. So this one I can times over by the negative 1. So it becomes negative 49 equals negative x squared. Okay, then I'm going to divide both sides by negative 1. So where are my critical values? They're at negative and positive 7. Okay. Critical values. Where is another critical value or partition number? Go back to the original. We can't have 0. So we have another one at 0, and this is a partition. Partition, not partial. I don't know if I spelled that right now. It looks totally wrong. Probably because I wrote it so fast, my handwriting's sloppy. Okay, so what are we going to do next? We're going to go, okay, if we did a sign chart and we have negative 7, 0, and 7, we could find where it's increasing and decreasing. And I mean, but for this problem, I don't even know that that would be the route you'd really want to go. It might be helpful to know for local min, local max, to know if a number is could possibly be our absolute min or max. So we could do that for that reason. This one happens to go positive, negative, negative, right? Now I don't remember, and then positive, because that's an absolute min. So it's going down, then up. Yeah. So that's what that one ends up looking like. So we could do our sign chart. That way we can see that these two are possible local min. Well, we know they're a local min, local max. But we could check if they're our absolute. Okay. So one way to kind of look to see if it is an absolute min or max is looking at concave. Now I think this is probably more work than just graphing, but let's do that by hand. So what we're going to do is do that second derivative, okay, of this. So the 1 goes away, and then negative 2 times negative 49 is 98 x to the negative 3. So we can write that as 98 over x to the third. So really the only value I'm going to have for this one, critical or inflection point or anything, is going to be 0. inflection point, right? And so if we did our little sign chart with the 0 with the second derivative, okay, so we have to put in something less than 0, so maybe -1. -1 to the third is still -1, so this is negative, because a negative divided into 98 will be negative. Over here, 1 to the third is 1, divided in is going to be positive. So that tells me that on one side, we are concave down, and we're concave up. So we're concave down where that -7 is. So if we think about this a little, and maybe I'll just show you it on my phone. I can't open up Desmos or it locks up my computer. So I found it's easier if I do it this way. So if we look at the graph, this is what it looks like, which is exactly what we found. We have a local max, local min 7 and -7, and then we can see at 0 we're concave up and concave down. But what do you notice about absolutes? We can't be concave down with our max knowing this is above. So neither one is our absolute. This goes down forever, that goes up forever. So there is no absolute max or min. Okay, so this is a tricky one. Oh, sorry, things in the way. I'm holding my phone in my hand. No absolute max or min. So there is no absolute. There is a local, but not an absolute. Okay, so when you're doing these problems, try to do some of the math just to get, don't just look at the graph to find your absolute max and min. Try doing the derivative, and you can use that second derivative for concave, because this one I could see it was concave down, but then this one's above it and concave up. Now, I can visualize that'll probably pretty easy, and then be like, well, this is above this one, so this can't be our absolute max. And that one is below this one, so this one can't be our absolute min. But it might take looking at the graphing calculator for some of these harder ones. Okay, so there's one harder one for you.